Okay guys, welcome back to TJ LearnX. This is part 4 of our project-based ETABS course where we continue designing our G+6 building step by step. Before we apply any loads to the structure, we must first understand and define load patterns. Load patterns tell ETABS what type of load is acting on the structure and how the software should treat that load during analysis and design. For defining the load pattern, I'm coming to the define tabs here. Then in load pattern, now here first we have to define the dead load. If the self-weight multipliers is 1, it means ETABS automatically calculate the self-weight of the structures. If this one is 0, then you have to manually give the ETABS the loads or the dead loads of the structure. Next, we have to define the live load that's already defined by the software here. The live load and self-weight multiplier is 0, and in the upcoming parts, we will give the ETABS this live load manually. For multi-story buildings like a G+6 structure, lateral loads are very important. We define seismic load patterns according to the selected design code and seismic parameters. For defining the lateral loads, we here choose the seismic right here, name of the seismic loads or seismic load in X direction, and I'm clicking here on add new load. Then type is seismic is correct, and I just changed the name to EQA Y, the seismic load in Y direction, and I'm clicking on add new load. You can see the EQX and EQY has been added successfully. We have to define the EQX and EQY, and for that I'm clicking to modify load. And now for seismic loads we have to choose here the codes. I'm using the IS 1893 2002 and modify load. Then also for EQY I'm choosing the IS 1893 2002 and clicking on modify load. We have to also modify lateral load here, clicking on it, and also see the seismic zone factor. We can change it here, and you can know from the code that 0.36 is for high seismic zone. This factor is for high seismic zone, and this is the site type. The site type is medium. Medium is the site type that I am constructing this structure. And importance factor is 1. This program calculated, and the direction and eccentricity, because it is EQ in X direction, I am uncheck this in Y direction. Then I am response reaction factor is 5 correct, and I am clicking on OK. Do the same way for EQY, modify lateral load and uncheck this in X direction because this one is in EQY, this one is in Y direction. And then the other parameters are OK, and I am clicking on OK here. We have to also define the wind load here, and now we have to define the wind load. Wind load in X direction, I'm writing here wind in X direction, type is wind, and I am changing the code to Indian IS 825 9087. Then add new load, and the same way for wind load in Y direction, and clicking on add new load. Then modify lateral load here, and these parameters are okay when the speed is 50 meter per second, train category, structure class, risk coefficient factor, and everything here is correct, and I'm clicking on OK. And if you have any other loads, you can add here, like partition wall loads, floor finish loads, or any loads that you have on your structure, you can add here. And remember, if load patterns are defined incorrectly, the entire design output will be unreliable, and you have to only give the self-weight multiplier of 1 to dead load. For all other loads, it has to be 0. If it be 1 for seismic loads or lateral loads, then ETABS will calculate it twice, because ETABS already calculate the lateral loads from mass source. In the next part, we will apply these load patterns to slabs, beams, and other structural elements. Don't forget to subscribe to get notified about the next part, and also hit the bell icon.